So my name is Peter McLean, TOA Regional Sales Manager for Atlantic Canada, Manitoba, and Saskatchewan. And today's topic is our SR-D8 series active steerable line arrays. So this is, for those that aren't familiar, this is a little bit different, product to play around with, solutions, an application than you may be usually dealing with. But we'll get into the basics and the benefits and features, and we'll try to bring up some examples where I've used it in past projects where it's performed quite nicely. So, a bit of overview. The idea with line arrays is to, in general, put audio where you need it, and keep audio away from where you don't need it. And that's a function of having a microphone element stacked in an array fashion. Now, the SR-D8 is a little bit different in a few ways, is that it is amplified. So it's self-amplified, a built-in digital amplifier. And it is DSP controlled. So there is software to control, basic EQ settings and so on and so forth, and wattage. But it does allow you to steer, and it plays with phasing and relationship between various drivers to basically put audio or aim audio in areas that are desirable and keep it away from areas that are not desirable. And the ultimate effect is to produce clear, accurate sound without reverberations in a space. So if you look at a little picture, we could sit there on a stack, and you'll see on the left-hand side, let's see, a little pointer here. On the left-hand side, you'll see where the speaker is located. You'll see the stack of line arrays to the left, and they can be changed to potentially split to cover a near field on the floor in an application, and the top stack could be focused right on, balcony seating and so on. So we look at components, and this would be one SR-D8. We have an 8-channel amplifier, so we're individually amplifying the speaker drivers, the power supply, and DSP control. We also have network connection and LAN and CobraNet connection, as well as analog audio input on the SR-D8s. So these are software controlled, and there's a visualization within that software to show you the coverage angles in order to accurately put the audio where it needs to be. So if you look at the pictures going through, let's see what that one too. You can see whether we're doing a straight shot across in a room, covering, maybe with a certain stack, we just want to cover the upper balcony. Maybe you want a little bit of dispersion below that upper balcony to cover not only the upper balcony and a little bit of the rear of the tiered seating up front. We may choose one of the cabinets or all of the cabinets to cover near field. So, the seating right in the front of a theater, per se, or a performance area, lecture hall, something like that. Or maybe you want to split it. We can potentially split the boxes and say, okay, depending on the area, we can cover near field on the floor seating that is tiered, as well as upper balcony seating. So you have lots of flexibility as to how and where we cover. So the principle of it, although not described in detail, the SR-D8 changes direction by projecting sound by changing the timing at each unit outputs. So basically the timing in between all the various speakers. So if you look at the picture, each one of those circles would represent a driver, and each one of the driver may be throwing a sound at different times, which affects phasing and delays and where that, and where the coverage goes in a certain area. Potentially canceling out areas where you don't want sound and focusing on areas where you do want sound. So looking at the equipment itself, on the left is the SR-D8M, which is main, and then on the right is the SR-D8S, would be sub. So the SR-D8 is your main unit. If you're just using one or two of them, you're going to start off with this unit. So it's got an analog input, 1 and 2. We have CobraNet to be able to link multiple units together, a local link out, LAN connection, fault control, you get your AC, and a status indicator. So again, on the right, we have the SR-D8 sub. So you have fault signal, CobraNet, link, LAN, fault control, what you notice is we don't have analog input. So the audio from the main is being sent over to the sub via Cobra connection. So the 3 SR-D8 sub speakers can be connected to an SR-D8 main. So you have a maximum of 4 connected in an array together. So look at a little bit of a system configuration here. So we get the SR-D on the D8M on the left, as well as on the right. You got potentially, an output from an analog mixer or maybe a digital mixer, but we're dealing with an analog signal going out, going into the SR-D8 main, where we have software, piece of software to control that, as well as on the right, where we have Cobra single sending over to SR-D8M as well. So this is consists of one SR-D8 main, and this is being a main and connected to the PC via network to control and offer the software flexibility with the unit. So adding to this, as I mentioned, we can get up to 4 speakers in one stack, and you'll see that on the right-hand side. So we've got the main unit on top, we've got our analog input, or it could be, a Cobra output as well, going to the first main, and local basically control and daisy chain from the main to the sub, to the next sub, and to the next sub. Just transferring the signal as well as DSP control for the software. PC, the GUI can control up to the 4 stacks, consisting of 4 stacks, so you get 16 boxes in total is what the software capabilities are to control. So you'll have 4 stacks of 4 is the maximum unit coverage, which is fairly substantial. I haven't done a project that large, but it does allow that flexibility should you have a facility that requires that kind of distribution. Looking at some of the bracket options, I won't get too much into this, but there's lots of bracket options for wall bracket, wall mounting, anchors to mount them together, pivots and tilts, joining, flying. So a big plethora of various mounting options are available, depending whether it's a single speaker or it's a quad stack configuration. Looking at the kind of the chain of software and how we go together. They can, the audio functions can roughly be divided into 3 sections. We've got the mixer, we have the DSP, and we have the beam steering and the unit of 8. So we've got mixer, DSP, and beam steering. So on the mixer side, we get the 2, mixer 1 and 2, we have analog 1 and 2, and they have Cobra outputs. That goes in the DSP side for the processing and equalization and so on. And then we have the beam steering is the next section after that. So the above illustration shows structure 4 cabinets. There's no need to think about the range of 1 speaker on the figure 1. A system composed of 4 when they are linked together. So same idea is that we've got the audio, the mixing section of the main unit. Then it goes to the subunits, the 3 subunits that work in unison to provide the proper beam steering that's required. And again, in each box, there is 8 drivers, so there's 8 amplifiers that allow you that control and focusing on each cabinet individually. The software GUI provides all control, mixing, digital signal processing, EQ, beam steering, simulations. And the simulation section is really nice because you can change angles and set up distances, and you'll see visually, similar to an E-spot, where that coverage of the speaker is intended based upon your calculations of the room, where you're mounting at, and all of your distances. So it does give a nice visual representation of the coverage and the focus of the beam. We do have the functionality to mix 6 inputs, mixing the 2 channels to feed the unit. So there is, a bit of a functionality there if required. Channel 1, channel 2, mix routes, and 6 channels, direct routes. It's connected to the DSP section, so they go right next to the DSP. And the DSP has some, basic functionality like mute, You can play with your gain settings, your high pass, low pass, filter, compression, delay, and grouping functionalities. This good illustration you'll see there where we've got the input meter, mute, gain, low pass, filter, compression, output meter. So that'd be the signal flow through the software of the SR-D8. Now we'll get into a little bit of the beam steering functionality. So this section simulates and sets the beam. So we've got a variable beam angle, minus 45 degrees to positive 45 degrees. And a width of 0 to 45 degrees. So splitting the beam in two directions and adjusting the width and vertical angle of each beam. Regardless of the number of speaker boxes, the maximum number that can be set is 2 directions per stack. As you see that illustration. Horizontal angle will be fixed at 90 degrees. There's kind of 3 sections. They're set in bulk and they can be called up when needed. The maximum of 32 presets. So you could have different presets depending on how the room is being used, or maybe seating capacity. Maybe you are using the upper balcony and the floor, or using them together, or not using the upper balcony. So there's no sense of throwing audio where nobody's maybe seated. Just reduce reverberation in certain areas. So you can have various presets where you have the mixer adjustments. You have the DSP functionality as you went through, as well as the beam settings can be saved to each one of up to 32 presets. So lots of flexibility. And maybe the room configurations, maybe that's tiered seating, temporary staging, it's flat, ground type seating, and then again, like maybe upper balconies, different areas of the room, which all could be set up and configured differently depending on the application, how the room may change. So the software is not only setting, but also speaker state monitoring. And if there's any issues, whether it's temperature related, current, which is the powering of the signal, if there's issues there and fluctuations, it'll notify you. Signal level, as well as peak indicators, if there's any, overdriving, as well as mute control. But the temperature setting is nice depending, on the facility and where they're mounted, and definitely the current. A lot of times we'll put these into, my experience is putting them in older houses of worship, really can't run new wires and cabling and so on. So the power sometimes can be an issue, so it gives you a notification of that clean signal if there is any issues to notify of that. And that's all done via the software and the GUI. Bypassing DSP, if the audio output is interrupted due to failure in the built-in DSP, or the current CAP processing analog inputs is available. So you can bypass the DSP and just go analog audio inputs, and to get through if there is some issues with DSP, if there is a fault or something like that, you can bypass that section and directly feed the units and amplifiers and the speakers. So there is kind of a redundancy there in signal flow, which is nice. So now we'll get into some application. This one here is a large mosque. The biggest physical challenge is how to attach speakers in the central large space, shown here in the blue square. So there's no pillars to attach the speakers to in this area. You have only, installed speakers, large speakers, but if installed the bad, a bad installation method, the speaker can create reverberation. So what that means is you're limited to where you can put the speakers. There's no area and no mounting to put speakers where, preferably you may want to. And that's where a line array really will come into play, is it allows you to put a speaker in an area. It's kind of a problem-solving tool in an area that, is not necessarily the best position to put a speaker, but when you have no options to mounting, you're kind of stuck in certain areas. So it allows you to play with inadequate mounting areas to offer you proper coverage patterns. We're looking at mounting off of this post here in the main speaker. You're going to get tons of different delays going off pillars, roofs, different levels and railings and everything else. So it's all going to add to the reverberation and lack of intelligibility in that room. So you end up, again, you're going to have, bad sound. You're going to play with a lot of EQing, trying to get rid of some of that reverberation, which a lot of times will reduce fidelity in those spaces. So if we look right here, sorry, this one here, we look at the coverage with a line array. So again, you can really contour that coverage area for the floor. So you're keeping the audio away from those upper balconies or upper areas or aesthetics or pillars that are going to basically play with the reverberation and reflection of your audio, and keep it down to where it's required. So that's one particular speaker in an area to cover that wide floor space. My experience with the SR-D8s is more related to, your conventional older house of worships. So a church has a strict design requirement, and unfortunately, I guess it depends. The older facilities do have fairly good acoustics. Newer may take as much in consideration with room deadening materials and things like that. A lot of them look quite nice, but maybe audio was not something they overly thought about in the effects of the architecture within. So I've had, my experience is older house of worship, older church. One I did in Newfoundland, Basilica over in St. John's, Newfoundland, and they need to upgrade their audio. And it was basically one large room with two side rooms off the side of it, kind of vestibules off the side. And we were limited to where the existing speakers were mounted, probably 30 years ago, for reason that there was asbestos, it was a historical building, so cutting, mounting, pulling wire was not an option. And the speakers, were not at all where you probably want them to be. So, the solution, the SR-D8, was allowing us to put a speaker very similar to we see on this wall up front, and allowing us to really contour the audio to where we need it to be and keeping it away from where we don't want it to be. A lot of times that's the hardest thing. We can blanket an area with sound, but keeping that sound away from areas that will cause acoustical interference is always the trouble. So that's what we did, and that's some application that I've used the SR-D8s in areas where you were kind of stuck to where mounting might be. So some specs, on the SR-D8, we don't need to get into a lot of those right now. You can feel free to check out, our website at TOA-Canada.com and look up SR-D8s or some information, application brochures, and so on to get into that side of things, but they are there. The one thing I wanted to bring up is to reach out to your RSM on those applications. We can use ease in the modeling within the SR-D8s themselves to look at a room and see if this would be the proper solution for sound reinforcement and to reduce reverberation. So feel free to reach out to the RSM. We'll talk to our tech department and involve them. One thing that I've done a lot in the past is, demos of the SR-D8. So we do have a demo kit, and that's what I use on the facilities, almost every one that I've used, just to illustrate the benefits of a steerable line array to allow you to, again, to contour coverage in a facility to offer that kind of solution. And the big advantage too is that you're not stuck, again, equalizing out a lot of the full frequency and dynamics of your speaker, trying to reduce reverberation of low frequency and highs that are causing feedback to open microphones. So the idea of any type of audio solution first is the right speaker in the right place. But there are instances, like I mentioned, like a mosque or house of worship, where you can put the right speaker in, but it can't always be the right place. So this is a solution when you can't put the right speaker in the right place.